Hello everyone, and welcome to This Week in Hearing. Today we will experience what I believe is the first implementation of Auracast in a large transportation hub, in this case Bristol Temple Meads railway station in the UK. Some issues need to be resolved in order to make the experience perfect. For example, all receiving devices being able to switch between transmitters seamlessly as you walk about the station, and implementing a priority system so one can listen to something else when announcements are not being made. But still, Auracast in this environment has a lot of utility, and it is important to get such facilities online in order to be able to refine the implementation. An exciting new update I tacked on to the end will show just how far Auracast can go in improving experiences like this for everyone. Let's begin with a tour.
Hi, I'm Jonathan Hoskin, Business Development Manager for Ampetronic Specialist Solutions team. We're here at Bristol Temple Meads demonstrating our trial installation of Auri across the Bristol Temple Meads station, supported by Catapult connected places. And now we're going to demonstrate the installation for you. So we have transmitters installed across the station. The first one of which is installed in the ticket hall here to give passengers access to audio information as soon as they get into the station. The transmitters are broadcasting the public address information directly to users' devices via Auracast. Now we're going to walk through the station and show you where the rest of the transmitters are installed and demonstrate the system. Before we move through to the station to show the rest of the transmitters, it's important to get an understanding of what the existing assistive listening provision is in the station. This is a grade 1 listed building, which means it's very difficult to integrate things into the material of the building. So unfortunately in this station, the limitation of assistive listening is that at the reception counters, there is a one-to-one local communication via an induction loop system. There are some other sporadic provisions across the station via help points, but no large area coverage systems to allow users to access the public address information. This is where Auracast can really add benefit to a scenario such as this, where we can provide complete coverage of the station very easily with a number of transmitters, which we'll go on and show you through the station now. So now we've come through the ticket gates from the main ticket hall through to platform 3, which is the first platform you reach when you get through those ticket gates. And you'll see above my head the Auri transmitter, which is covering a large majority of platform 3, allowing users to access the audio information as they walk up and down this platform. As you can see, this platform is currently under refurbishment. There's a fair amount of construction work taking place, but it's not affecting the performance of the system. You've still got very good coverage across the majority of this platform area. Now what we're going to do is take you through the subway area, which links all of the platforms together, and demonstrate the coverage in that area, all the way through to platforms 9 to 11. So now we've walked down the stairs from platform 3 into the subway. We have coverage across the entire subway with 3 Auracast transmitters. As you can see, the subway has a large amount of metal and a lot of construction features that could mask the signal, but we still have very good coverage across the entire station. So we've now walked through the subway and demonstrated coverage across the entirety of the subway. We're now going to transition up to platforms 9 to 11, where we have coverage across those entire length of platforms, and demonstrate the coverage up there for you. So now we're arriving on platforms 9 to 11. This is the largest coverage area on the station for Auri, where we're covering well over 200 meters of platform area. Interestingly, this platform is on a curvature, which can make it quite challenging to cover with an Auracast signal, due to some masking from buildings across the entirety of the station. So you'll see the transmitters dotted across one side and then the other to ensure that we have adequate coverage across the entire platform.
For your own safety, you are reminded to stand behind the yellow line.
So we've now moved about 30 meters down from that initial position on these platforms. As you could just hear, there was an announcement just came through. You should be able to hear how clear that announcement is, and the significant improvement upon the acoustic announcement made through the speakers. Now, The coverage here is complete from the first position down to this position. There is no dropout, which allows the users to roam between transmitters very easily. Now, if we were to cover this area with an induction loop system, it would require a significant amount of cable integrated within the materials of the platform itself, buried underneath the concrete, for example, and a significant amount of drive equipment. So currently we've covered this very large area with 2 transmitters. It's likely if we were going to do the same thing with an induction loop system, it would take approximately 4 amplifiers and a significant amount of cable, thus increasing the cost significantly.
Please note, to ensure a timely departure, train doors will be locked shut up to 40 seconds before departure. Thank you.
So as you may have been able to hear, station environments can be particularly noisy acoustically, and particularly when trains are entering and exiting the station. This is where we can benefit significantly from audio being delivered directly to our earbuds, for example. We can still hear the clarity of announcements even when a train is entering and exiting the station. As you can see above our heads is the next transmitter, again approximately 30 meters down from the previous position. So now I'm standing outside of the covered canopy area of platforms 9 to 11, just to give you a demonstration of the extent of the coverage across these set of platforms. I'd like to walk the length of the platform now to show you. So as you can see, it's quite an extensive coverage area, all the way across the canopied area to the outside area of the platform.
So thank you, John, for being with us today. It's really, really interesting what you've done, and I'd like to break it down just a little bit. First and foremost, how actually did that project come to be?
Well, thank you for inviting me, Andrew. It's a real pleasure to be here. In terms of how the project came to be, well, everything kind of really began with the Station Innovation Programme, which is run by Connected Places Catapult here in the UK. They were looking for technologies that could make stations more inclusive. They had a set of challenges to answer, one of which was an accessibility challenge. And they're particularly interested in passengers who find it difficult to get intelligibility from station announcements. So those that have hearing impairment, those that potentially don't speak the local language natively, potentially those that have neurodiverse conditions could all benefit from this sort of solution. So we put Auri forward as a solution. So Auri is the Ampetronic brand name for our Auracast transmitter. And we proposed that it could deliver the station's live PA feed directly to personal devices, hearing aids, cochlear implants, earbuds, smartphones. And as you know, without pairing and without relying on other technology being present everywhere. So we were fortunate enough to win that competition. And then we were invited to deploy the solution into Bristol Temple Meads train station. They refer to it as their test bed. And from that point, Connected Places Catapult fully supported the project. So we worked alongside Connected Places Catapult, Network Rail, the R&ID helped us shape the research. Also, integrators and passenger experience teams were all involved from the really early outset of the project. And what we really wanted to achieve was obviously to trial the product, but beyond that, we wanted to get a real understanding of what it takes to implement this sort of technology in this space to make audio more accessible across these major transport hub type environments.
And in the context of this particular railway station, what made Auracast attractive over other possible systems?
That's a great question. So Bristol Temple Meads is particularly interesting in terms of construction. It's quite an old station. It's actually the home station of Isambard Kingdom Brunel, who is a very famous engineer in the 1800s in the UK, designed many bridges and train stations and all sorts of things. And the station is what's known as a Grade 1 listed building. That essentially means that you can't do anything to the material of the building that might change its aesthetics. They want to try to preserve the original aesthetics and the original construction of the building, which means integrating things like induction loops is particularly challenging. An induction loop system typically requires cable to be integrated into the material of the building. And given the train station is over 100 years old, closer to 200 years old, really, it's almost impossible for us to do any of that invasive engineering. So they were really keen on the Auracast transmitters, which are powered over Ethernet, and simply don't require a huge amount of infrastructure to integrate into the space. And I think that's really what made the solution so attractive to the station.
Okay, that makes a lot of sense. And I have to add that, yes, any building like that that goes to the beginning of railways in the UK and is the place where Winston Churchill got horsewhipped by a suffragette deserves to be a Grade 1 building. But you can't simply tear up the floor to lay loops in, even in limited places, correct?
Yeah, sure.
Okay, so then this being a large facility, you obviously have multiple transmitters. How do you actually site the transmitters, plan their locations in advance so you know you're going to get the coverage you want?
So initially, it was all about site survey. We got to Bristol, and our priority was to design something that would work in a real life environment, not just a lab. So we had to carefully survey and also map some of the propagation, if you like, from the transmitters, and understand the building structures, especially any potential structures that could mask the signal, and also looking at the really long spans of some of the platforms. So where we have coverage, platforms 9 to 12, the platform itself is well over 200 meters in length. So we need to make sure that we had adequate coverage across that entire length of platform without getting significant masking from those buildings and things along those lines. Now we have an in-house design tool that allows us to design the propagation of the RF, of the Auracast signal, and we use that to simulate how the coverage would interact with various construction features and bits and pieces like that. But also there was a little bit of a degree of using our foundation knowledge that we've learned over the period of time developing the solution. We've tested it in a lot of different lab type environments, got an understanding of how much of a dampening effect certain materials might have, certain thicknesses of materials. So we took all of that into account when designing the system. The system in general was relatively non-invasive, and effectively we were able to place transmitters where they were actually in an effective position rather than in a convenient position, based on the length that we could go with Ethernet, for example, or power supply or something along those lines.
Okay, so it's pretty clear this is a very complex installation, but if I'm to summarize it, you could take all those factors and accurately determine the transmitter position in advance, correct? Because you don't really have a lot of latitude to move things around like you might in a single transmitter theater. So you were able to simulate it, and then the end results were what you expected, so there wasn't a lot of rework to be done?
Absolutely correct. The positioning of the transmitters didn't have to change after our initial simulation. The orientation had to change slightly, and that's just simply because our transmitters are slightly more powerful in one orientation than the other. So we just had to point them in the right direction. But the positioning was absolutely fine, which was fantastic. It's also worth noting that originally the scope we were working on was just to cover the platforms 9 to 12 and the subway section that leads you to those platforms. But very early on in the program, CPC, Catapult Connected Places, or Connected Places Catapult, sorry, I got that wrong. They asked if we could extend the coverage. They could see quite early on the potential advantage of an Auracast solution to their passengers. So we ended up extending the coverage to the ticket hall and the concourse area leading to the main area of the station. And we secured additional support to do that. And it turned out to be really valuable. Those areas have the highest background noise and the highest footfall. So we got a lot of really great feedback from that area. But it did mean we had to go back to the drawing board and do some additional simulations and calculate some additional Ethernet and power quite early on in the project.
Okay, but that makes perfect sense because the ticketing hall, not only is it loud, but it's also with elevated ceilings, and I've got to imagine it's really reverberant, so it's hard to hear the announcements anyway.
Yeah, absolutely. It's quite an incredible building. The architecture's fantastic, sort of Gothic style architecture, if you like, but it does come with its own challenges. As you say, very high ceilings, very reverberant, not fantastic in terms of acoustics. The other thing that might be worth noting with regards to setting up these systems are proprietary receivers that we offer with systems when they're going into traditional AV type environments like theaters and cinemas and spaces like that. They actually have a mode built into them that allow us to check for signal strength and also packet stability and things along those lines. So we can measure the RSSI levels, the received signal strength, across the station. So not only were we able to simulate the solution and then use various different consumer devices and receivers to listen to the received audio, we were also able to measure it in terms of a discrete value of RSSI, for example.
Yeah, signal strength. And that's a good point to make for people who are considering DIY installations in less complex environments, that you can take that receiver right here and do signal strength analysis as you walk around the location. So you were able to do that as well. Now, this is clearly in the social media posts that were done, there was often mentioned quote unquote demos, but this is clearly a permanent installation, correct? It's not going away. The meaning of the demo is just that you were taking people through to experience it, but this is going to be here more or less forever now, correct?
Well, what's quite interesting about the test bed, if you like, is initially it was designed to just be the summer of 2025. So installed in July and removed at the end of the summer, in the autumn time. So it probably should have been removed a couple of months ago. Since the trials have been so well received from various stakeholders, CPC have actually asked us to leave the kit in the station, which is fantastic from a technology perspective and an accessibility perspective. But it also means that we can support other trials which want to use modern methods of delivering audio to an end user. So we're actually in discussions now with Connected Places Catapult and some other technology providers for how we can support trials moving forward. So it's likely our system will be in place for as long as Bristol Temple Meads want us to leave it in place. And it seems likely that that's going to be for a prolonged period of time still, because there's a lot of potential additional applications that could be supported by Auracast. So for example, maybe multiple language streams, for example, or delivering curated content specific to a passenger's journey and things along those lines. So we've been asked to support a lot of those similar type of applications in the future using that technology. So although initially it wasn't intended to be left in the station for a long period of time, it looks as if the effectiveness of the system has persuaded those that control that side of things to keep the system in for a longer period of time, just simply because it can benefit a lot of other applications.
Yeah, and what a great test bed in the real world to be able to try out those advanced applications like multiple languages, for example. Now, you intimated this a couple of times, but I want to ask, how was the reception? I mean, how did people react to the Auracast installation? You know, positive, negative, in between? Like, how did people react to it?
In general, the response was really great, very encouraging, both technically and from the passenger experience side. I will caveat that by saying, and you very deftly mentioned it at the beginning, there are some features that need to be elaborated on for it to become really, really effective in these types of environments. But the improvement that the system has made over and above the incumbent assistive listening that was there is night and day. It's extremely encouraging, the response we're getting from people. And to give you a summary of some of those tasks, the RNID ran some formal research. The RNID is the Royal National Institute for the Deaf, for those that don't know, including things like digit triplet testing. And the majority of the participants showed a measurable intelligibility gain when they were listening through Auri compared to the PA alone. And a lot of them had actually talked about how it reduced their listening effort, made consonants clearer. And many of them actually said it was the first time they could follow every detail of an announcement in the station environment. So that in general is an extremely rewarding response from it. Now, over and above that, from a technical perspective, we held a number of what we call experience days with various stakeholders, device manufacturers, accessibility groups, system integrators, rail operators, the types of stakeholders you'd expect to be interested in this sort of deployment. And those sessions helped validate some of the user journey side of things. And one of the interesting responses we had from a transportation perspective was that with regards to onboarding, actually connecting to a stream, NFC is far and away the preferred method to join a broadcast in a transportation setting. And the reason for that is that certainly in the UK and Europe, it's very common to tap onto a bus to pay for your fare, or tap onto a piece of public transport, a tram or something along those lines to pay for your fare. So being able to tap on and also potentially connect to the audio stream is something that would be not too much of a departure for how the user would interact with a vehicle typically, or a piece of public transport typically. So that was something that we hadn't necessarily looked at in a huge amount of detail initially. It was QR codes were the initial onboarding process that was looked at in across many different implementations of Auracast, but I think the NFC onboarding is something that could be very important. So overall, the solution was extremely well received from all aspects, really. But there is some development and evolution required in the standard to really meet all of the necessary goals that we have for providing accessible transportation.
Okay. Yeah, I think actually the NFC tap-in system really makes a lot of sense. I'd never thought about it. I thought in certain environments, making people tap in means you might end up with long queues, for example, at the entrance to a theater while people try to tap in. The queue is building, right? But in the railway environment, it makes a lot of sense just for the reason you said. It's the same in the public transport system in Chicago, too. Tap on, board your metro, and you're off and running. So people are used to doing that and are used to doing it quickly as they go through. So what a great implementation for NFC. Now, you talked a lot about potential future plans in Bristol, but how about expansion throughout the public transportation system in the UK? What are the chances of that? What do you think are the timeline? How do you imagine that would take place?
So Yes, I mean, it's a great question. We have a lot of interest from other transport operators already in the UK. The UK transportation market, I suppose, is a very good way of putting it, is quite fragmented. So the UK uses a franchise-based system where an operator will have they will run a particular operation of vehicles for a period of time, and they will bid for it every X amount of years, which means that there isn't necessarily a consistent standard to all of the provisions. Now there is a minimum requirement for accessibility and the like in rail stations and bus depots and things like that in the UK. So there's a minimum specification, but often operators tend to like to improve upon that, or some like to do the minimum. But I guess, going back to your initial question about expanding the system, I think one of the really important parts of designing the system, and one of our goals when we design the system, is to try to make the configuration as transferable as possible. And effectively, what we did when we designed the system for Bristol Temple Meads is created a system that was a standalone network, which means that we can deploy it in other stations that have similar challenges to Bristol Temple Meads in a very simple and quick and easy way. So we're already in a discussion with, in fact, very late ends of discussions with another train station operator in the UK. I can't say a huge amount about it now, but it's likely we'll have another pilot running in the UK early next year. And we are also talking with other operators across Europe as well, most recent of which being in Germany, who are very interested in producing a pilot study in one of their major stations, most likely either being Berlin or Munich, which was quite exciting. So I think operators can see the advantage of the technology, can understand that it potentially resolves a lot of their accessibility issues. But there's some proof of concept still to go through yet, to get to the point where we can start to look at mass adoption over larger areas and larger stations.
Well, no, I mean, to me, this is really exciting because this sort of thing, airport gates and train stations and so on, have been discussed almost from the beginning of Auracast. Now it's actually coming to fruition. Problems are being worked out. Improvements, are being considered, and we're now on our way, and it's very exciting. Anything else you want to add about this particular implementation or what's coming in the future?
I think it's worth just noting the implementation that we designed for Bristol Temple Meads allowed us to prove that we can overlay a system over an existing PA without any risk. And I think that's a really important part to mention. Certainly in the UK, we have a lot of legacy audio systems in our train stations. So if we can prove that we can create a risk-free implementation that's very non-invasive and can be trusted, it makes the system significantly more attractive. But also, I think the way in which we design the system allows for very easy scalability. And we haven't mentioned that yet. Compared to a lot of other assistive listening technologies, scalability of Auracast is extremely easy. It's effectively another PoE channel on your network switch and another transmitter. If you were to expand a loop system, it's a significant amount more complex. It's more loop cable integrated into the material of the building. It's a significantly more invasive approach to expanding, and the same thing could be said for other technologies. So I think that's probably one of the key parts of this trial, is that we proved that we can do it in a very risk-free, non-invasive way.
Okay, no, that makes a lot of sense. And you're never going to loop an entire train station anyway. So then if you decide to do that and you did decide to cut into the floor to lay the cable down, you're essentially penning people into, a penalty box, if you will. You can't go to the cafe or you can't go to the washroom. You're going to lose the signal if you do. So,
Yeah, absolutely. I think that's one of the keys that we've all often tried to have people understand with induction loop systems is that most people don't travel on their own. Most people travel with friends or family. If you're providing a limited coverage of assistive listening, where do the friends and family go? Do they go and stand in the same? I like the term penalty box with the person that requires access to the audio, which potentially then makes it a lot smaller for anyone else that requires access to the audio. Or do they leave that one person off to stand in that area on their own while they go and freely explore the station or wherever they are? So I think this presents such a significant advantage from an end user perspective, but also from a passenger experience professional's perspective as well. They're always trying to deliver the best quality of service to a passenger, and I think Auracast really gives us that opportunity to do so.
yeah, agreed. And it isn't necessarily an either or, right? The loops have tremendous utility at the ticket windows and so on. But when you want to move about freely in the station, there seems to be no other way other than Oracast.
I think you've hit the nail on the head there. I think certainly for the next few years, that a hybrid of both technologies would make a lot of sense. And where your end user has a telecoil enabled hearing aid, they're likely to find that it's still the simplest method of getting assistive listening at ticket windows is using an induction loop system. But if they want that freedom of movement and want to be able to explore an environment that they're in, then perhaps an Auracast solution in conjunction with loop systems in that space is the right solution.
I think that's a perfect statement of the future. And I very much appreciate you, first off, creating the video tour, and second, spending some time with me so we could learn more about this aspect of Auracast implementation. So thanks a lot. I appreciate your time today.
Thank you, Andrew. It's been really great. Thank you.
A few months ago, I wrote a LinkedIn post challenging smart glass companies to incorporate Auracast so that live transcription of the audio feed could be displayed. Imagine what a benefit that would be to deaf people, or really anyone who wants to get updates visually without having to look down at their phone. The caption glasses company X-Ray was already rising to the challenge, commenting on my post that we have a very exciting Auracast announcement coming soon. Then, about the time this podcast was being put to bed, X-Ray publicly announced that they had been selected to participate in the same accelerator grant program as Ampetronic at Bristol Temple Meads. So this idea will in fact become reality, including language translation too. How exciting is that? I can't wait to see it in action. I'll be sure to report on it, but for now, thanks to you all for watching or listening to This Week in Hearing.